Voice is muted.
Welcoming the guest is a part of Code of Conduct for Indian culture. I request our technical team to present virtual bouquet on behalf of Honorable Chancellor Shri Purushottam Das Ji Pasari and Vice Chancellor Dr. Upinder Dhar to our chief guest, Professor E.D. James. Thank you, sir. Life of Shri Vikram Sarabhai is like a beacon in superstitious night in India's development of space and nuclear power. An inspiration for future generation, he always said, he who can listen to the music in the midst of noise can achieve great things. With these words, I request our technical team to show the glimpse of life of Shri Vikram Sarabhai.
Vikram Sarabhai was known as the father of India's space program. It was Sarabhai who put India on the international map in the field of space research. He worked in the fields of textile, pharmaceuticals, nuclear power, electronics and many others. Vikram Ambalal Sarabhai was born on 12th August 1919 to a wealthy family at Ahmedabad. Sarabhai had his early education in the family-run school. After completing his intermediate science examination from Gujarat College, Cambridge in 1937, where he obtained his tripos in natural sciences in 1940. At the outbreak of the Second World War, he returned to India and joined the Indian Institute of Science at Bangalore, where he took up research in cosmic rays under the supervision of C.V. Raman. He published his first research paper entitled Time Distribution of Cosmic Rays in the Proceedings of Indian Academy of Sciences. His visit across several science centers enhanced his interest in solar physics and cosmic rays. In 1947, he also founded Physical Research Laboratory in Ahmedabad. In India, he studied interplanetary space, solar terrestrial relationships, and geomagnetism. The most striking aspect of Sarabhai's personality was the range and breadth of his interest and the way in which he transformed his ideas into institutions. Sarabhai was a creative scientist, a successful and forward-looking industrialist, and more. With support of Homi Bhabha, he played an important role in the establishment of first rocket launching station in Thumba near Thiruvananthapuram. After the death of Homi Bhabha in January 1966, Sarabhai was appointed as chairman of Atomic Energy Commission. Dr. Sarabhai was awarded with Shanti Swarup Bhatnagar Medal in 1962 and Padma Bhushan in 1966. On 30th December 1971, the country lost its great scientist and an innovator of the highest order.
I request our technical team to pay tribute to Shri Vikram Sarabhai virtually on behalf of our Vice Chancellor and our distinguished speaker. Thank you, sir. Now I request Honorable Vice Chancellor Dr. Upinder Dhar sir to welcome our guest by his warm words and gesture. Over to you, sir.
Good morning to all of you. At the outset, I would like to extend a very warm and hearty welcome to our distinguished speaker, Dr. Ms. on this very special occasion. Our university is a very young university. We celebrated 10th Foundation Day this month only on 8th of January. 9 years back, when government of Madhya Pradesh declared this institution as a university through a gazette notification. One of the challenges before us was that how to be different, how to do different things, and important things, of course, differently. And one of the activities that we chose was to ensure that our students and young teachers are inspired by the sons and daughters of the soil. Our students are familiar with the names of the scientists and scholars of the origin of other countries, who have origin of other countries. But it is not very common to know the contributions of the scientists who were born in India. Therefore, we felt that we should establish some orations in the name of some leading scientists of the country who have contributed a great deal. And our students need to know about their contribution. You see, when it comes to physics, we start with Newton. Newton, of course, has contributed, no doubt about that. But there are many other scientists who have also contributed, even before Newton. For example, Aryabhatta. Therefore, we started in 2016 with Aryabhatta Memorial Oration. And the first oration was delivered by Padma Vibhushan Anil Kakodkar. Then we felt that we should go ahead and make the names of other scientists familiar amongst our students, and so that they get inspired by Indian. It is not that scientists are born in West only. Great scientists are born in India also. So we set up C.V. Raman Memorial Oration, followed by Srinivasa Ramanujan Memorial Oration, Mokshagundam Vishveshwarya Memorial Oration, and of course, Vikram Sarabhai Memorial Oration. These are all great names. And our students need to know what contributions these great people have made and get in turn inspired. We are very happy that today we have Dr. James with us as distinguished speaker. Though he will be speaking on his own work on the topic of his interest, but purpose of this oration is to remember the contributions of Vikram Sarabhai, as we have seen just now through a short film, that Vikram Sarabhai was a versatile person. On one hand, he was an industrialist born in a business family. He was a music lover. Himself, he played various instruments. Great person and institution builder. He was the person who facilitated the establishment of second IIM in the country, that is IIM Ahmedabad. We have just now heard he established National Physical Laboratory and many more institutions. Since I have lived in Ahmedabad, I used to be director of Nirma Institute of Management. There are many institutions and even professional bodies like, say, ATIRA were established by Vikram Sarabhai. And of course, as a great scientist, he is considered the father of space science in India. What we are seeing today, the successes that we are seeing, one success after another success in space science. The initiatives were taken by Vikram Sarabhai at that time, and others followed. Though he was student of a great scientist, C.V. Raman, and was also had the opportunity to work with Homi Jahangir Baba. But then his contributions are no less. So we remember Vikram Sarabhai today as a great personality, a great scientist, a versatile person. And we welcome Dr. James on this occasion. I'm sure that all of us will feel enriched by the deliberation, by the oration, which will be delivered by Professor E.D. James. So once again, welcome to Sri Vaishno Vidyapit Vishwavidyalaya on the virtual platform. Thank you very much.
Thank you very much, sir. Your this vision only give us an opportunity to talk to the living legends and to know about the scientists of India. Thank you very much, sir. Now I request Coordinator Center of Excellence Plasma Research, Professor Uttam Sharma, sir, to introduce distinguished speaker, Professor E.D. Jamis, to the audience present over here. Over to you, sir.
It is a matter of pride privilege for me to read the citation of Padma Shri Professor E.D. Jamis. I quote, Professor E.D. Jamis was born on 31st October 1951. He is a Year of Science Chair Professor of ACRB at the Indian Institute of Science, IISc Bangalore. His primary area of research is applied theoretical chemistry with emphasis on structure, bonding, and resistivity across the periodic table of elements. Spanning over wide areas such as polymorph of elements and their compound, organic and organometallic chemistry, and structural chemistry of the main group. Professor Jamis studies chemistry at IIT Kanpur, Princeton, and Cornell University. Before joining the University of Hyderabad in 1980 and IISc Bangalore in 2005. He was the founding director of Indian Institute of Science, Education and Research, Thiruvananthapuram, that is ISER TVM, between 2008 to 2013. He has been a member of advisory board of several international journals in chemistry and served the interest of DST, CSIR, UGC, BRNS, IASC, INSA, universities, IITs, ISERs in many capacities. He is an honorary professor at JNCASR and adjunct professor at ICTS TFIR, Mumbai. He has given several hundred invited lectures and seminars across the world. He has mentored 30 PhD students and several postdoctoral students and research associates and have published about 200 research articles. His accomplishments have been acknowledged through various awards and recognition, including Shanti Sarup Bhatnagar Prize, Toas Prize. He is a Fellow of Indian Academy of Science, Bangalore, Fellow of the Academy of Sciences for the Developing World, J.C. Bose National Fellowship of the Department of Science and Technology, New Delhi. He was awarded 4th highest civilian award of Republic of India, Padma Shri in Science and Engineering category in 2014 by Government of India. Unquote. Shri Vaishno Vidyapit Vishwavidyalaya is privileged to present this citation to Professor E.D. Jamis for delivering the prestigious 8th Vikram Sarabhai Memorial Oration as distinguished speaker on 23rd January 2024.
I request our Vice Chancellor, sir, to present the citation to Professor E.D. Jamis virtually. Thank you, sir. Now, not taking much time, I request Professor Jamis to please deliver 8th Vikram Sarabhai Memorial Oration on importance of early questions. Over to you, sir. I request audience to please put their questions in the chat box for question and answer session after the oration. Over to you, sir.
Thank you. Thank you very much. I thank all of you for the thought of inviting me. And Sri Vaishnava Vishwavidyalaya is indeed taking extra efforts than most other universities that I know in getting the students know about the past successes in science in India and how we can proceed further. Now, when I was giving an abstract for this talk, I hadn't thought enough. But afterwards, I felt what I have to say about Professor Vikram Sarabhai is far more important than what I have done. And so I will spend some time to talk about some general things that I know about him by being here, and then come to some things that I would like to specifically speak. So may I share the screen now? Is that okay?
Please share, sir. Visible, sir?
Yes, all right. So I will make it full screen.
Yes, sir.
Is it okay?
Yes, sir. Is it okay?
Yes. Now, obviously, I am influenced by my institute all the time, and so I keep my institute's main building in the background. But you know, it is indeed a privilege even to be online with Sri Vaishnava Vishwavidyalaya's faculty and students. I have given this title, Importance of Early Questions. But before I do this, let me say what I have as a plan in mind. I would spend some time talking about Vikram Sarabhai. And you know, that's more to tell how an individual with his abilities, with his affluence, with his intelligence and experience, with his family background, have succeeded in doing so many things in such a short time. You know, Vikram Sarabhai lived only 52 years. What a loss it is for the country that he didn't stay a little longer. I will then spend some time about questions that we need to ask, and questions of various kinds, whether it is inter, multi, cross, disciplinary, all kinds of questions. And I will give just one question that I had asked early on, and that led to the rest of the talk. Vikram Sarabhai, you know, 52 years, and we always talk about Indian space program, but it is not just the Indian space program. Indian space program is just one of the many things. Imagine this: Physical Research Laboratory, headed the Atomic Energy Commission, established the Indian Institute of Management, Ahmedabad, first Textile Research Cooperative, Athira, first Market Research Organization, ORG, Space Application Center by combining many institutions. And of course, he has been making sure that the pharmaceutical business that Sarabhai started it goes on. He actually caused the beginning of Uranium Corporation of India Limited. And with his wife, Mrinalini Sarabhai, he could get the Darpan Academy of Performing Arts. And I put the research into cosmic rays and PhD thesis and all at the end. So this is remarkable for an individual. In 50 years, 52 years. In fact, I had the good fortune to be with Dr. Amrita Shah, wrote a biography of Vikram Sarabhai. Vikram Sarabhai Alive, that was the title. And I must say, this is a book everybody should read. You know, he came from an aristocratic family, philanthropic, sophisticated, humanistic. He had family friends, Rabindranath Tagore, Mahatma Gandhi, well connected with everybody in the world, prime ministers and presidents, scientists, sociologists, humanists across the world. But what he did with all this influence, he used all powers to propel the nation into a bright modern era. He did not just live for himself. He made sure that everything possible within his powers is done to propel India to a bright modern era. And that is unusual. That is unusual. Not every rich is idle. Not every rich is concerned only with money. He was unusual in every respect. In fact, you know, when he had to go to Cambridge, it is Rabindranath Tagore who writes a letter to Cambridge saying that this is the person who should be admitted. Imagine that. We had celebrated the 100th year of his birth in 2019 at the Indian Institute of Indian Institute of Science. And we had just the few lines that I will show. He came to Indian Institute of Science, I would say by accident, the accident of the World War. And he felt, yes, he could continue his research in the C.V. Raman, in IISc. What is interesting is that Homi Bhabha was here on a vacation from England, and he couldn't go back because of the war. And he was appointed as a reader in IISc, and there was the young Vikram Sarabhai working with him. And it is incredible what they did. Of course, they did something beyond. I will read this out, or maybe you can read it. It's just incredible. He had a taste for everything that is really outstanding. But he didn't just live with that. He went beyond it. In fact, when he was not meeting Baba and the others, Vikram would wander down the road from Ramalaya to Vedanta College, run by the Ramakrishna Mission. He would seek out the priests there and chat with him about Hindu philosophy. These conversations clearly had an impact on him, for he was to refer to them in a public lecture in 1962 describing how struck he had been by the great concern of ancient Indian philosophers with questions about the nature of knowledge, of the role of the observer, and of the qualitative recognition of aspects of relativity. Now, he is definitely a very unusual person. Unusual person in the sense that he could get things done. He could get things done at the most difficult circumstances. Vikram Sarabhai and Abdul Kalam and others selected a particular place for the equatorial electrojet, where an equatorial electrojet exists. And this happened to be the location of a church. And Sarabhai had no second thoughts. He could go to the church and convince them that, look, this is a church that you have to give for Indian science. And Kalam writes in his autobiography something very interesting. Kalam writes, in ignited minds, unleashing the power of within India. The priest was convinced rather the people were convinced that what Vikram is doing is equally important and we should just give the church. And the church was given. The church is actually the first office of the space research of India. And Vikram is the one who did it. Now, Vikram has not done just this. He has done many other things. I will give you one more. Now, this is from the autobiography of Abdul Kalam again. We had a problem. We had a problem of defense, and we didn't have a missile defense strategy. And though Vikram was really involved in research in space, he said this is necessary. And how does he do it? He gets people involved to come the only time available to him. It is written, ungodly hour of 3:30 a.m. when Vikram meets Abdul Kalam and Captain Narayanan. So this is the individual who is not normal. We don't see such people often. And this is what I would like to tell the new generation. We have to make sure that we are really doing what is important for the nation, not just important for X or Y. This is something very unusual and we have to learn from Vikram Sarabhai. In fact, Vikram Sarabhai built a culture in VSSC. And in general ISRO, a culture to reach out to anybody who needs it. In 2009, when I was the director of ISR Thiruvananthapuram, we had difficulty in the second year to accommodate our students. And it took me only one call to the then VISC director, who later became the chairman of ISRO, to get their training hostel for our students for a year. This is the culture that Vikram Sarabhai has generated. Not every department of the government is of this kind. So this is the individual who makes a difference to anything that he touches. Now let me come to questions. It is said that the success of nations depends on the ability of its citizens to ask original questions, innovative questions, probing questions, new questions that will bring in innovations that one can never imagine. And this is really something that I would like to spend a little time. Geniuses like Vikram Sarabhai would not require a training, but it is not necessary to be a genius to be able to ask questions. Anybody can be trained to ask questions. But it is the duty of our teachers, right from school, parents, the society, to train them to ask questions from the beginning so that people would really be innovators throughout their life. And it is necessary to start asking questions early because early questions tends to be general and more difficult. If you ask somebody finishing PhD, think of a question that you would like to answer. It will invariably be related to his thesis, already specialized. If you ask somebody who is just beginning graduate study, at least he would say, okay, I had a basic degree in physics. He could talk about anything in physics as a problem, or in chemistry or whatever subject that he has studied. But if you go down further, a beginning undergraduate student, he had no preoccupation. Could be any question under the world. But in the high school, it is even better. This is where we have to get students to ask questions. We have to encourage them to ask questions so that general questions will come. And it is nothing surprising because that is the way the universal education began when civilizations began. It's nothing surprising because when civilizations were young, questions were more general. Same scholars did everything. It is Varahamihira or anyone else, who could ask the question. Aryabhatta was not just in one field. It was possible for them to ask questions in every field, and that is what makes the difference. And we have to start this early on. In the beginning, it was all the same. we had then divisions because of high specializations. And those inevitable specializations, it is not really a helpful thing in many ways. Children are almost like the beginning of a civilization. They don't know enough. So their questions are original. This is what is important. And questions tend to be very broad. In fact, each one has an experience. And from now on, I will stick to my experience. I will talk about what I have seen and experienced myself in these areas of asking questions. I was watching as a student, a graduate student, I was a chemistry graduate student doing PhD, and then there was a mathematician. He did his undergraduate degree in mathematics and went on to do PhD in mathematics as a Rhodes Scholar and continued in mathematics for the next 10 years. But after 10 years of being a mathematician, he felt maybe something is not sufficient. And he was free to think about biology, learned biology, not just learned biology. When Harvard and MIT together established the so-called Broad Institute of Genomics, they could locate only Eric Lander as its director. This is remarkable for a mathematician. I'm saying this because we have so many compartments. When we go to BSc, BA, BCom, and I hope the university is different, the one that I'm talking now, right? I feel that Sri Vaishnav Vidyapith should be different, where students should come for undergraduate study and they should be able to do what they like. We don't normally have it. We go to a college, we have BSc, either physics with the mathematics and chemistry, or mathematics with X, Y, and Y. We don't have BSc where I can learn mathematics, I can learn physics, I can learn history, I can learn music, and then after a couple of years, I decided to specialize. This is necessary. We should not be put into an option box in the beginning. I would say Sri Vaishnav Vidyapith is in a position to change this norm. It is unfortunate that the British gave us this boxed education 150 years ago. 120 years ago, they changed. We are holding on to it. Fortunately, if you use the new education policy correctly, we have the opportunity, but we should take it seriously and use it correctly. We should not be just namesake doing it. We should get students to come to the university and take courses and then decide what they should like after a year, 2 or 3. In fact, ICS have just begun a little bit, but that's not enough. We talk about our IITs. IIT Bombay, computer science. I mean, you have to enter there, and it is very difficult to get out into history. This is unfortunate because, when we look at history and history majors across the country, we see people who are not the greatest of scholars in the +2 going to humanities and social sciences. This is not what happens in the world. I again come back to the only institution I know well, Princeton University. The top 15% of the SAT score people in Princeton goes to history, not to computer science. This is something that is abnormal. We have historians, not good enough because we don't have people going to history that way. We don't have people going to social sciences. The number one will not go there. Why? It's the problem that we have of the society, of the teachers, of the students, of the system. We should change it. Now, I'm getting excited because one should take history, but of course, one need not stick to history. I talk again about a historian who became a physicist and a mathematician. It is not common. In India, if you take BA history, it's unthinkable that that person will go to physics and mathematics later. But I'm talking about, again, my experience at Princeton. When I had a classmate who joined in physics for PhD, but his major was history. And we asked him, why? Why from history to mathematics, physics? And he said, I wanted to look at history earlier and earlier periods. You can go 10,000 years, 20,000. But if you want to go further and farther backwards, I have to be a physicist. I would like to go to the Big Bang and see how it all began. So history major did not prevent him from becoming a physicist. And this is not an ordinary man, Edward Witten, who got a Fields Medal in mathematics for developing the mathematics that he wanted to do in physics. Now, what did he develop in physics? He developed string theory. He's the originator of string theory in physics. Now, I say all this because there is this university, Sri Vaishnava Vidyapeeth, who has an opportunity to change the system and make it accessible. In a sense, a very bright and rich man doesn't have to go to Harvard or Princeton. They should select here. Now, this next part I will skip because I am already running late, because I spoke a lot more about questions and Vikram Sarabhai than I wanted to. But let me let me say that early UG specializations is an antithesis to the idea of innovation. We should change it. Now, let me give a personal example. When I was a first year BSc student, I asked a question. I asked a question to a teacher. We had a Professor Sangaraya in the University College in the first year BSc, who was telling us about the structural chemistry of carbon. He said there is sp3 hybridization, tetracoordinate carbon, methane, ethane, cyclohexane, and it gets to diamond. He said there is benzene, naphthalene, anthracene, Huckel 4n+2 rule, and then we have graphite. Those days we didn't know about graphene. Now, when he was walking out of the class, I asked a very casual question. Is there anything like this for boron? That's all I asked. And he said, let us look at what is there in boron. And I didn't get an answer. I went on to do an MSc in IIT Kanpur. I asked the teachers. Well, they said, not really. We do not know how compounds of boron and elemental boron are related. Not very common. Then I continued this question. I thought I will go for PhD and ask this. But when you go for PhD, what happens is, you have this feeling, I'm going to do research, whatever I want. But when you get to the professor as a graduate student, then you do what he tells you to do, right? And later on, you do not know what happens. But I had an advantage. But the advantage was that in Princeton, for the PhD final public oral exam, we did not have to defend the thesis, but we had to suggest 3 research proposals and defend that this is doable proposals. And I had the same question about boron there. Now, this helped me in many ways. I continued with this question, and I did not get the answer until 2000. 30 years since I asked the question. But when I got the answer, it was interesting. But those 30 years, I, of course, did other things as well. Otherwise, I didn't have a job. I worked on many things. I list these things which are more of chemistry. But the question that I had answered, I would say I formulated the question better. And now I formulate it as though it is a modern question. We know all of these things. Anybody would know graphene. Even sociologists talk about graphene nowadays, right? Graphene is very well known. And I ask this question now. Is there something similar for boron? I refine this. Excuse me. I refine this question further and put this way. we all know about boron as next to carbon, and there could be chemistry related to carbon. Ethane, there could be corresponding dianion with boron. There is NH3BH3 which is equivalent. There is hydroboration. A whole lot of things which can be connected with the carbon chemistry. But that's not as interesting. If we consider that it is not because it is not interesting, but it is because it is known and it is obvious. For hydroboration, we have a Nobel Prize. Now, boron compounds can be far more complex than the carbon chemistry. We have polyhedral boranes. Polyhedral boranes, there is VIII N+1 skeletal electron pair rules. These are all chemistry questions. But here also, a lot of people have done a lot of work, and a Nobel Prize came in which year? 1976. So these are still chemistry questions that are understood, but we have to go beyond. And what is the question beyond? How do we relate boranes to elemental boron? Now, this is a tough question because it is easy for alpha rhombohedral boron. It is a little hard for beta rhombohedral boron. I am not going to discuss this in greater detail because once we published in 2001, the idea using a specific rule, it became, this is too complex a picture. I don't want to spend any time, but it became textbook material. So what we published in 2001 is there in all these textbooks. It is being taught all over the world, and it is old news. I do not want to spend time on it. But chemistry students might learn this, but I would like to spend time on what is happening now in boron chemistry. And a preview of the things to come, I indicate here. We have polyhedral borane, condensation and going to beta rhombohedral boron and so on. We have 3-membered rings going to graphene-like sheets and graphene-like sheets getting stuck. So this is a graphical overview of what is to come. Dr. Ksadi, I should probably be warned when I have to stop. How many minutes I have for my own new result? Roughly.
No, sir, it's a really very interesting.
Kindly carry on, no problem.
sir.
We are enjoying this.
Good. All right. So let me now come to something that I can explain to +2 students. What I had done earlier in the last 3-4 slides are really for chemists, only chemists. But this one is easier. Now, for benzene, the equivalent is graphene. We all know this. If you remove all the hydrogens from B12, H12, we have something flat, more like graphene. But if you make a two-dimensional sheet out of it, it is like this. Almost like graphene, except every 6-membered ring has an additional atom in the middle, right? We have 6-membered rings and an atom in the middle. So this is triangulating. This is borophene, just as graphene. Now, this is a new material that is just coming through, and this is what I would like to spend time on. Now, this is understandable to everybody because, it's like graphene. It is like graphene. Addition to graphene, there is an extra atom in the middle. All atoms are boron, not carbon. The only problem is that when we look at the stability of this, it looks as though it is not flat. It is kind of triangulated. A layer goes up, another line goes down, and so on. Now, if you remove some atoms here, if you remove some atoms and make some hexagonal holes, then we find that it is more stable and it remains flat. Right. And then we could go further. We could go further because if we, well, of course, we need to have people to work with. I had several students who were very bright, except in 2007. In 2007, I went down to end of 2007. I decided to take up the job of starting a new institution. And so this particular research was not continued for long by me. But in 2013, when I got back, I got again a student from IIT Kanpur. The one who finished in 2005 is actually a faculty member in IIT Kanpur. Now, the student from IIT Kanpur joined, and then we continued this and said, why is it that you take a triangular sheet and make some holes and suddenly it is more stable? So we calculated this and found that if you don't have any holes, it is not the best. 0 is the most stable value I have given. If you have one hole for every 9 boron atoms, this is the most stable one. If I have more holes, it is not stable. If I have less holes, it also is not stable. This is interesting. How do we understand this? This is a computational result. How do we understand? Understanding means different things to different people. For Charles Coulson, who was a famous chemist, he says, give us insight, not numbers. But modern day, we could say, give us insight and numbers. This is the success of computational chemistry. But there are people who say, like Wigner, even if the computer gives you the right result, computer may have understood it, but I would like to understand it as well. Now, understanding has a different meaning. Let us look at this picture cartoon very carefully. We have an accurate quantitative approach to have a kennel for a dog. But if you don't have the qualitative understanding, the dog has a problem. Right? So we need a qualitative understanding along with quantitative result. And so we went back and said, what is it that makes this more stable? In fact, when we were doing this, these are all speculation. But in the last 5 years, these are made experimentally, right? The graphene equivalent of boron. But why is it that 1/9 hole density is the best? And this is easy to understand. Easy to understand because we all understand graphene, right? Graphene is a hexagonal sheet with carbon. Now, if I were to replace each of the carbon by a B-, which is isoelectronic, then we have equivalent of magnesium boride. Magnesium boride is a B- graphene sheet, and for every 2 B-, there is an Mg plus 2. So we have in MgB2 a layer of B- graphene, another layer of Mg plus 2. Of course, the charge is not fully separated, but that is MgB2. Now, for the moment, let us assume that we are replacing Mg by a boron as well. So this Mg will be replaced by a boron. When it was Mg, it was in a different plane. It was alternating plane. If you replace it by a boron, you have BB2, right? BB2, whether the boron comes from replacing Mg or the original one, they are all boron. When it was Mg, Mg was not in the middle of the ring because it was a larger atom. But with this, all atoms come in the plane. They are all in the same plane, right? Excuse me. It is triangulating. But why holes? When we replace one Mg by a boron and we get this triangulate, there is only one problem. One Mg and one boron, there is an extra electron. If you consider now Mg3b6 and B3b6, we have 3 electrons extra compared to compared to the Mg, right? When we have 3 extra electrons, it is not the same as graphene. It has 3 extra electrons per 9 boron atoms. Now, if you remove one boron, we are removing 3 electrons and getting back to the electron count of graphene, right? Graphene, we know, is stable. It has all kinds of unusual properties. But we have now a borofene, which will have a few holes, not a few. It is exact because we have B3b6. We would like to make it as B2b6. When it is B2b6, instead of 9 boron atoms, we have 8 boron atoms. So 1 hole for every 9 boron atoms. That's the most stable one. If you understand this, then we understand the rest of the electronic structure of borofene, because people have studied graphene in great detail. They have studied borofene in great detail. what is amazing is that the properties of borofene is better than that of graphene, except it is not as easy to make. But it is made as a uniform layer on a metal surface, usually on 111 silver surface. And when it is made, one finds that it has even more holes than the 1/9. That is interesting because we calculated this again and we found that yes, it is 1/9 hole density if it is only the standalone sheet. But when we put it on a metal, the number of holes are more because a metal like silver would like to stabilize it. It can stabilize it by giving electrons. And for giving electrons, it should have some demand. If it is 1/9, it doesn't require it. So it has more holes, like 1/5 or 1/6 or 5/33. As it increases, you have a greater stability for this. Now, this is a speculation. We can say, no, that is what is found experimentally as well, right? We published this and there is a lot of interesting stuff that came afterwards. Now, we can ask the question, are there ways of reaching electron efficiency without hexagonal holes? This is where something very unusual happens. When we take graphene bilayer, solid state physicists would know it has unusual properties, depending on the angle between the two layers. But it is still a van der Waals kind of interaction between the layers. But we have a possibility of doing something very unorthodox. That is, take two borofene sheets without any holes. And look at this. A borofene sheet, another borofene sheet. Let us pull out one boron from the middle of a hexagon, pull it down. From the other one, pull it up and form a boron-boron bond. Now, if you form a boron-boron bond, it's a localized two-center two-electron bond. We have removed one electron from this layer. We have removed one electron from this delocalized picture. Now, if we have 3 such bonds formed, right, for every 9 boron atom, without any holes, we have already removed the right number of electrons. 3 electrons are removed. So a bilayer with 3 interlayer two-center two-electron bonds is isoelectronic to graphene or borofene with 1/9 hole density. Now, this is schematically indicated here. There is for every 3 boron, every 9 boron on the top and every 9 boron at the bottom, we need to have 3 BBs, two-center two-electron bond. Now, this could be speculation, we can say. Computational chemists can speculate. And we speculated it in 2018. Now, surprising, 2022, just a year ago, 2 experiments, again on silver surface, of the bilayers made, right? So we didn't have to wait too long for the prediction to be found true. The difficulty, of course, is that it is on the silver 111 surface. There has to be ways of getting it out. And we are working on those now. But even more interesting is that this exercise of bilayer can be done for trilayer. If you do the trilayer, we see that if you do this 1, 2, 3, 9 boron atoms and 3 bonds, the middle layer has the right number of electrons. The top layer and the bottom layer has only half the number of the holes required. So we could then increase the number of holes here. We could, of course, go through this kind of exercise and make tetralayer, pentalayer, and so on. And with each of these, we could have by the stacks like what is there in graphene. So there is a whole lot that we learn from this exercise. I would stop this and say that this is the larger picture that I would like to paint. And we have a so-called Rudolph diagram of standard inorganic chemistry textbooks that can be extended now to have the 3D and the 2D part. Let me remind, it all began with a question in 1968 in the first year BSc, and the answers continue to come after so many years. And these questions are what makes me feel every student should learn to ask questions all through. And that's the only way to get our regular program going without any difficulty. Now, I have left out the 3D part of it, which is too complex. Now, what I have done in my BSc program here, last 10 years, except this year, last 10 years, I taught third year UG students in IISc. Now, those students are the very bright ones in the country. Most of them have an IIT JEE ranking below 1000, and they wanted to do science and they have come here. Very unusual, bright group. And to them, I tell, even from the first year, start writing down questions on anything that you don't understand. And many of them write down questions. And by the time they are in the third year, when they come to me, already they have 3-4 pages of good questions for which there is no answers yet. By the end of the course in the third year, they learn to ask even more probing questions. And, what do they do later on? In fact, 4 years ago, one of them wanted to go abroad for PhD. Now, he applied to Harvard. He sent a list of his questions saying that these are the questions that I want to answer. And what did Harvard do? Harvard sent him a ticket to come and see Harvard. Said that you come for 3 days, we pay for your ticket, we would like to talk to you, then you take a decision. And right now he's completing his PhD at Harvard. What I would like to say is that asking questions should be a part of our education on anything. It could be on science, it could be on humanities, it could be in sociology, it could be anything. But we should learn to ask questions that will get answers, and that probe continues and develops humanity as a whole. Now, I really thank Sri Vaishnava Vidyapith Vishwavidyalaya for many things. But the most important thing is that it forced me to go and read the biography of Vikram Sarabhai, written by a visiting professor in the institute here in IISc. And I had talked to her many times, but I never read her book. I read her book, and that is the best thing that has happened to me in the last several weeks. I would like to see that many students grow up to be Vikram Sarabhais in the country. We have the talent, we have to get it in the right direction. I was fortunate that Professor Veendra Dhar and Professor Uttam Sharma and all of you together decided that I should give this lecture. Dr. Nitu Katharia for organizing it. I have had really outstanding students. They are all largely in faculty. I have only vague ideas, and they convert that into really important projects. They are all over, and my current batch is small right here, and I really would love to ask questions and to be asked by students anything under the sun or above. Thank you.
Thank you very much, sir, for this wonderful oration, which gives us the importance of question, how a question leads to your life, and how the subject is not a boundary for the research and for learning and to get the answers. Thank you very much, sir. Now the session is open for the question and answers. Our panelists may ask the questions, sir. I have some questions on the question and answer box also. First, I
Yes.
read that.
Yeah, I have it with me. What
Yes,
will
sir.
be your message for students who confine themselves by not asking questions during a class? You know, it takes me, since I teach undergraduate students, I can answer this with some experience. You know, the students during the 12 years of schooling mostly have forgotten to ask questions. Not forgotten, let me say forbidden to ask questions. In most schools, if a student asks questions in a class, maybe one or two, okay. But if the questions become third one, the teacher will say, shut up, sit down. This is the problem. We force our students, we kind of make sure that our students are not encouraged to ask questions. And so the important job that I have in my first class in the BSc course that I teach is to get them out of it. So initially, when I open this and say anybody can ask questions, only 2 or 3 will ask questions. Then I change my strategy. I have the names of all the students. I ask questions to them specifically. 1, 2, 3, like that I follow. And of course, the exercise that I do in IASC, I don't know if I can suggest to everybody. See, I do not teach a class. I tell them that we will discuss this particular chapter tomorrow, and I mean in the next class, and say that our aim will be to see what all parts of that class, that text is wrong. It is outdated textbook. The textbook is already 15 years old. Most of it, many of it is not right. And I have a group of students who takes my challenge. Then not everybody takes the challenge. So I ask individually each one, look, there is this problem. What do you think? So the answer is that I take the initiative asking them till they realize that there is no harm in asking questions. If I ask a stupid question, this teacher is not going to reduce my grades. If I ask good question, he might be excited, but I get only few chances because the next question is to the next student. So I force them to ask questions. Is it
Thank you, sir.
next question? Shall I
Yes,
go
sir.
to the next one?
Yes, sir.
Is it practically possible to have more elements?
Okay, thank you very much, Professor Emis. It was very absorbing session. And we would desire that next time you visit us in physical mode.
Well,
We would like to interact more with you.
thank you.
Thank you very much.
Very kind of you to stay on this long. I did not realize the Vice Chancellor of an institution can stay on in the science part of the talk. You would have hundreds of things to do. I mean, I know from my experience of starting a new institution, it is all encompassing and consuming every minute. So I really appreciate your, staying on, Dr. Binder, this long.
No, your session was very enriching. So we have learned certain basic concepts which I didn't know. Thank you very much. So can we close this session now, please?
Yes.
Sir, we have some few questions more
Yeah, please.
with your permission, sir.
Yeah, we should
Yes,
have
sir.
some questions.
Yes, sir. Sir,
I would not like to impose on the time that you have. I mean, I would not mind stopping now, but I can also answer questions if you feel that way is better. Dr. Katharia.
yes, sir, is it practically possible to have some more elements having possibility of exhibiting chemistry similar to carbon and boron?
See, nature has given us the elements, and we could, of course, make modifications to them. So we can combine them, just as I said, magnesium boride is superconducting. 40 degree Kelvin. Graphene doesn't superconduct. Graphene bilayer, I mean, at the same temperature, graphene bilayer at a particular angle becomes superconducting. We have now lots of people trying many combinations, not just borofene, but silicenes and metal main group combinations, large numbers. So it is not as though there is a yes or no. I would say always yes. The question of not more elements, more combination of elements. Yes.
Thank you, much, sir. So gradually we have reached to the end of the program now. I request Secretary Shri Vaishnav Vidyapit Trust Shri Kamal Narayan Ji Buradia sir to present the vote of thanks. Over to you, sir. Sir, you're muted, sir.
Unmute, sir, yes.
Yes, sir.
आज के हमारे 8वें विक्रम साराभाई मेमोरियल ओवेशन कार्यक्रम के मुख्य अतिथि प्रोफेसर पद्मश्री ईडी जेमनीस साहेब, वैष्णव विद्यापीठ विश्वविद्यालय के कुलपति डॉक्टर उपेंद्र धर, कार्यक्रम संयोजक डॉक्टर उत्तम शर्मा, सभी फैकल्टी मेंबर्स, निर्देशकगण, विभागाध्यक्ष, शिक्षकगण एवं प्यारे छात्र छात्राओं, आज के इस कार्यक्रम के मुख्य अतिथि के रूप में ईडी जेमनीस साहब की गरिमा में उपस्थिति के रूप में हम सभी गौरवान्वित महसूस कर रहे हैं। उनका, जैसा कि मैंने उनका अभी उद्बोधन सुना, डॉक्टर ईडी जेमनीस का जीवन हम सभी के लिए एक प्रेरणादायी पुस्तक के समान है। उन्होंने आज हमें जो ज्ञान का लाभ दिया है और जो सहज रूप से प्राप्त हुआ है, सर, आपके बहुआयामी व्यक्तित्व के प्रकाश में हम सभी अभिभूत हैं। वैष्णव विद्यापीठ विश्वविद्यालय परिवार आपका इस अवसर पर आभार व्यक्त करता है। निश्चय ही आपके ज्ञान एवं अनुभव से हमारा उभरता हुआ विश्वविद्यालय समृद्ध हुआ है। आपने जो क्लासरूम में आस्किंग क्वेश्चन एंड टू इनकरेज क्वेश्चन, एक आजकल का एक बहुत बड़ा मुद्दा है कि जिसको आपने उठाया है, और ये बहुत ही आवश्यक है कि हम स्टूडेंट्स को क्वेश्चन पूछने के लिए प्रोत्साहित करें। और साथ ही जैसा कि आपने कहा कि मैं पर्सनली नाम से भी स्टूडेंट से पूछता हूं, ये बहुत बड़ी एक हम सभी टीचर्स के लिए एक प्रेरणादायी बात है कि हम इंटरेक्टिव क्लासरूम चलाएं और क्वेश्चन पे ज्यादा से ज्यादा ध्यान दें, ताकि हमारा क्लासरूम्स और अच्छे हों और हमारा विश्वविद्यालय समृद्ध हो। सर, मेरा एक आपसे विनम्र निवेदन है कि आप इस कार्यक्रम में वर्चुअल रूप से उपस्थित हैं। हम चाहते हैं कि आप इस विद्यालय में प्रत्यक्ष रूप से पधारें और हमें आपके ज्ञान मार्गदर्शन दें। इंदौर, जो कि स्वच्छता में पूरे देश में 7वीं बार प्रथम आया है, साथ ही इंदौर को और भी कई अवार्ड प्राप्त हुए हैं। आशा है आप इंदौर अवश्य पधारें, जैसा कि हमारे कुलपति जी ने भी आपको आमंत्रित किया है। आशा है आप हमारे निवेदन को स्वीकार करेंगे। सर, आपसे हम बहुत प्रभावित हुए हैं। मैं आपके लिए यही कहूंगा कि मिलते हैं मिन्नतों से ऐसे मेहमा कभी कभी, मिलते हैं मिन्नतों से ऐसे मेहमा कभी कभी, हो जाती है किस्मतें यूं मेहरमा कभी कभी, हो जाती है किस्मतें यूं मेहरमा कभी कभी। जज्बात जग जाए तो हम भी कुछ बने आप जैसे, सुना तो आपको लगा कि हम भी तो कुछ बने। मिलती है प्रेरणा किसी से कभी कभी, हो जाती है किस्मतें यूं मेहरमा कभी कभी। सर, मैं आज इस कार्यक्रम में उपस्थित सभी फैकल्टीज, एचओडीज, कार्यक्रम संयोजक उत्तम शर्मा एवं उनकी टीम का इस अवसर पर आभार व्यक्त करता हूं। मैं नीतू कटारिया का भी आभार व्यक्त करता हूं उनके अच्छे संयोजन के लिए। मैं डॉक्टर उपेंद्र धर साहब का भी बहुत बहुत आभार व्यक्त करता हूं कि उन्होंने इतने अच्छे गेस्ट को हमारे बीच में बुलाया है। और मैं पुनः डॉक्टर ईडी जेमनीस का आभार व्यक्त करता हूं। सर, आपका इकबाल और बुलंद हो। आप देश एवं समाज की ऐसे ही सेवा करते रहें। आप स्वस्थ रहें, शतायु हों। पूरा विश्वविद्यालय आपके सुखद भविष्य की मंगल कामना करता है। हम आपका पुनः अभिवादन करते हैं। सर, आपने कदम ऐसे रखे कि निशान बन गए, कार्य ऐसे किए कि पहचान बन गए। जीवन तो सभी जी लेते हैं, लेकिन सर आप ऐसे जिए कि मिसाल बन गए। आप कृपया इंदौर पधारें, हमको साथ हमारे को मार्गदर्शन दें। इसे हेतु मैं पुनः आपका अभिवादन करता हूं एवं आपको निमंत्रित करता हूं। बहुत बहुत धन्यवाद। जय जय हिंद, जय वैष्णव। थैंक यू वेरी मच सर। बहुत थैंक यू वेरी मच सर।
Thank you, sir. Once again, thanks to Professor Jamis and all the dignitaries and delegates present through this online platform. Thank you very much, sir. I request all of you to please rise up at your place for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मांगे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
भारत माता की जय।
Okay,
Thank you.
thank you
Thank
very
you,
much,
sir.
Professor James. Thank you.
Thank you all, and
Thank you.
sir.
Thank you very
Yes,
much,
sir.
sir. Thank you very much, sir.